take a pod, a pre-injection molded pod, fill it with a powder, weight check it, place a lid on that had to snap onto a center stem, ultrasonically seal that, and then discharge them onto an exit conveyor that went through metal detection and cartoning and things. That it reduces time, but also takes out some of the inertias from making it a strict square pattern. So being able to round the corners, you can begin the motion downward as you're still transversing. The Yaskawa servos themselves are smaller footprint than some of the competitors, so that's a huge advantage. And we use these in other applications. We really love the Yaskawas for their size, their strength, their reliability. They just made it very easy to implement this. In fact, we had it set up and running within perhaps an hour. Yaskawa worked very closely with our electrical engineer for designing these pre-canned programs for the tuning software. I'm happy with the results. I'm not certain how they did it, but I'm really happy with the results.
Audio Jungle.
We do preformed container filling and sealing. This one was different in that the pods don't stack together, so they are a loose pack and they had to go through a feeder bowl to be orientated and presented. Where normally the containers we do, you would stack them and they have a stacking distance so we could denest them one at a time out of a vertical stack. So that portion was completely different than what we normally do. And that's where the pick and place mechanisms came in, one for the pod, one for the lid, and then we also used one on the discharge because we had to flip these onto their top and send them down the conveyor on the top because the bottom was a tapered small diameter and they would tip over. They needed 30 indexes a minute, so we had 3 lanes. That was 90 pods per minute. So we have essentially a 2-second cycle, and we need about a little less than a half a second for indexing. So they gave us 1.5 seconds to pick the pods from the escapement and place them into the machine, which sounds like a lot of time, but it's pretty rapid because we had to move about 12 inches after we picked them out of the escapement and then go downward to place them into the platen or seat them on top of the pod itself after it was filled. There was some pretty good linear travel, so we had to pick and then move 12 inches and then downward about 6 inches. So we had a box pattern. In that regard, yeah, we had to make that motion forward and back in that 1.5 seconds. The choices were perhaps a robot, which I think would have been prohibitively expensive. It probably would have gone as fast as we needed, but it was an overkill for the scenario since it was doing a repetitive H pattern. So we were presented the H Bot and reviewed it, used it on a previous project, and it worked out very well. So we thought this was the perfect application for it. Well, the H Bot design has 2 separate servo motors that are mounted outboard on the linear axis. Then the belt goes between those motors and through the Z-axis. So you don't have the servo motor and the actuator on the Z-axis, so that reduces the weight and the inertia there too. So with the 2 motors, you have 2 smaller motors that work in tandem to get the linear motion. And then one motor will stop and the other will move for the Z-axis. So it's reduced the weight, it's made it quicker. You have 2 identical motors, so you have 2 identical drives. So there's a repetitiveness on the electrical design. They're all the same drives. And the inertia is less. They're very fast. The belt is very accurate. The belt is much faster than a ball screw. And the repetitiveness is just amazing. Very good speed too. In our application, we're probably running about 60% of the total speed capable of the H Bot, but it's plenty fast for our application. And to keep the machine as compact as possible, the H Bot worked beautifully because it's not very wide and it mounted nicely. It was a perfect application for what we needed. Less power consumption, less heat, less inertia. Well, with that linear axis, there's a lot of harmonics. because of the rigidity of the machine and so on, and it helped tune out those harmonics and made it very smooth. It kept the vibration of the machine to an absolute minimum. They just made it very easy to implement this. In fact, we had it set up and running within perhaps an hour of initial setup.